Okay. So, sorry for the inconvenience. I'll have to go over it again. So, as I earlier mentioned, today we'll be looking at the advanced JavaScript concept. And under advanced JavaScript concepts, we'll be looking at closures, prototypal inheritance, and functional programming. So, first on the list is closures. So, under closures, we'll be looking at definitions, how closures work, and how we can use closures in JavaScript. So, I made mention of actually defined closures. That a closure is a function that has access to variables from its scope, like its outer scope, even after the outer function has finished executing. So this simply means it encloses the environment and variables of its outer function, so that even after that function is finished executing, let's say it's been popped from the stack, it still retains access to the environment and variables, so it can use to, perform some other operations. So what this simply means is a closure is simply a function inside another function. So when the outer function is called, it is being pushed to the call stack, and then it invokes the inner function, which is pushed to the stack as well. So what happens here is, even after the outer function is done executing, the inner function still retains access to the variables and environments of the outer function. So the core concept behind closures is what we call lexical scoping. So what JavaScript uses is a lexical scope. So the lexical scoping here, what it simply means the function have access to variables defined in their outer scope at the time they were declared, not when the function is being run. They have access to those variables and environment at the time that function was declared, not when they are executed. So this is different from something like dynamic scoping, where functions would access variables based on where they are called. No, this is not. When you declare a function and then you declare another one inside of that function, okay, so the JavaScript engine recognizes it. Okay, so what you're trying to do is you're creating a closure. So how closures basically work is, when a function is defined inside another function, it forms a closure. Immediately you define a function inside of another function, a closure is formed. So the inner function captures references to variables from the outer function scope. Let me repeat this. The inner function captures references to variables from the outer function scope. And then even after the outer function returns, the inner function retains access to these variables. So it can use to, perform some other operations and return a result. So there's also a garbage collector in JavaScript. Every programming language has a garbage collector except languages like C and C++, I guess. Those are basically low-level languages or something. Yeah, basically low-level languages, because you have to do that by yourself. But for JavaScript, it has a garbage collector that keeps these variables alive as long as the closure references them. What this means is, when the outer functions execute, the inner function, which references these variables, it references these variables. So the garbage collector knows, oh, there's a function that is still referencing these variables and the entire environment. So I don't have to clean this up. I don't have to delete this. I'll have to wait for the inner function to execute before cleaning the environment or doing away with these variables. So that is basically how closures work. When the outer function executes and the inner function references the variables to the outer function, those variables are still alive. They're not being deleted or they are not being garbage collected until the inner function is done executing. So what actually is the memory model behind closures? So you should think of closures as creating a snapshot of the outer function's environment that travels with the inner function. So basically, each closure gets its own independent copy of these variables. Can you hear that? Each closure gets its own independent copy of these variables. So the key points here are just mainly inner functions have access to outer functions variable. That is the lexical scoping. The beginning of the inner body of the outer function and the end of the inner body of the outer function is the lexical scoping. That is the lexical scope. The beginning of the inner body of the outer function and the end of the inner body of the outer function is called the lexical scope. So variables remain accessible even after outer functions returns. That is, they are persisted because the inner function still references them. So each closure maintains its own independent copy of variables because those variables are being isolated for each closure. That means if you have a couple of functions, 2 or 3 functions in that function, each function references a different copy of those variables. That is what it's called isolation. So closures are basically created every time a function is created. Every time you create a function and you call another function, you create another function inside of that function, a closure is created. So that is basically it. So I guess for you to understand what closures really are, we should take a look at an example. Um, so here, this is my text editor. And let's take a look at an example of a closure. So let's say we have 2 functions, the outer function and the inner function. So we have, let's say this is the outer function. That returns, or let's say it, we have another function inside, which is the inner function, like this. So once we do this, a closure is formed. So we formed a closure basically, but we also want to access whatsoever it's done inside of the inner function. So in order to access that, because closures also form private variables. So in order to access that, we return, let's say we want to return the inner function like this. So we have 2 functions here. So basically what we can do is from here, like this. So this is the beginning of our lexical scope and this is the ending. So anything within here can be accessed in the inner function. But then if there's another function below this one, it can still access the variables in the outer function. So what we can do here is we can pass a parameter to this function, let's say m. And then this m can also be accessed in this inner function. So let's pass another one to the inner function, let's say n. Okay, so let me take you back a little bit and tell you how this works. So let's say we have this outer function with a parameter of m. So essentially, what we are saying here is we have m, and then let's say, let me remove this m and then do something like let m equal to undefined. So this is what we are doing. But the difference between the parameter and the variable we just declared in this function is that this m cannot be accessed outside of this function, or we basically cannot pass any arguments to this function without passing a parameter here. So this is what we are doing. If you pass m here, let's say m, what this function does is you are actually declaring a variable, but it will grab that variable, bring it inside of the function body, and then say let m equal to undefined, like this. So by the time you invoke this function and then do not pass in any argument, this is what will happen in the function body. It will grab this m and then initialize it to undefined, because you actually declared this m, but there's no value assigned to it. So this is basically how parameters work. So same thing here. Anytime you pass a parameter to a function, just know that that's how it will. And this m can only be accessed inside of this function, not outside of this outer function. So that is basically this is a variable, but the reason why it's here because we are trying to pass arguments to this function, so we can access let's say the outer environment variables. We are trying to access them inside of this function. So that's the reason why we pass them as a parameter, so they can be safely accessed and then manipulated. So now that we have two functions, m and n, so we can safely access this m inside of this function here. We can basically say return, or let's not return it. We can basically say log m plus n, like so. So as you can see, we are accessing this m that is being declared in the outer function. We are still accessing it in the inner function. So how can we see this in action? So now that we have a log that is logging both m, we're adding m to n and then logging into the console. So we can basically say, let's say add, okay, let's call this add 2, which is equal to outer function, and then we pass in 2. But if you log this to the console, you will see that this is returning a function. Can you take a look at this? Okay, this is look at this, should I call it a model or something? This outer function is actually returning a function. And then the inner function is returning nothing. That's why it's void. So if you call this, you will see that what you see on the console here, add 2. Let's see, node closures JS. As you can see, this is basically a function. There's nothing reasonable here. Inner function. This is what this add2 is returning. It's returning an inner function. So what we do is when we call add2 is returning a function. So we need to call that function, pass in another argument to actually get our result. So what we will do here is we will just call this, since it's returning a function, this function will be returned and then passed to this constant add2. So what we need to do here, we need to invoke this add2 because it's a function. As you can see, if you hover over this one here, I'll place, let's say something like this, okay? This is returning a function, n, which is of type any, and which returns nothing. So if you come over here and you invoke this add2, as you can see, this is the function it's returning. The function with the parameter of n, which returns nothing, which is this function here. So the parameter n, we can pass in, let's say 3. And now, okay. Yeah. And now if we call our function, node closures.js, we get 5. And then we get undefined. Okay, so we don't have to log this because it's returning nothing. But the reason why we're getting undefined is because this function is returning nothing. It's returning undefined. Because in a function, if you don't return anything, it actually returns undefined. So if you come over here and then say return undefined, and then run this function again, node closures.js, you see 5 and you still see undefined. But by the time you see return m plus n, then you see 5 twice. 5, 5, because we are returning m plus n. But if you call a function without returning anything, that function basically returns undefined. It returns void because void is like nothing, and undefined is like nothing. So that is basically undefined. Or if you say return void, uh, void something like this. Yes, void 0. This basically means in the early versions of JavaScript, undefined or null can be referred to as void 0. So you run this and then you see that it returns undefined. So this void 0 means undefined, means nothing. So you can basically omit this, or if you want to be explicit, you can basically return void 0 or leave it like this. And then this time around, remove the console log because we are returning nothing. So we just have to call this function, and then it will invoke our console log function inside of the inner function, and then 5 will be logged to the console. Now we see 5. Can you see this? This is amazing because now we have the outer function with m. Okay, so now let's say remove this m, then bring this m inside. Let's say let m equal to 5, like so. And then this time around, let's run this function again and see what we got. Okay, so we have 8. So let's remove this 5 and then pass in 2 because this is what we are passing. Then we can remove this 2 and we are safe because this function accepts no parameters, no argument. So we cannot pass any arguments. So we can come over here, clear our console, and then run it once more. Okay, clear. Then run this once more, and then we have 5. So as you can see, this is basically this. And then you can see m. Let's say m is equal to 2. So this time around, you are not saying, okay, this shouldn't be undefined. Even if no argument is passed to this function, m should always be 2. But if an argument is passed, let's say we pass 3, let this 3 overwrite this 2 here, this initial, we call it default parameters. So let it override this default parameter with a value of 2, and then become 3. 3 plus 3 will give you 6. And then if you run this code, you will see that we have 6 as our result. If you remove this 3 here, you are saying, I don't want m to be undefined, never. Because if it's undefined, it will break my code. So what I actually want to do is have a default parameter of m and then initialize it to 2. So if you run this code once more, you have 5 because no argument passed, but the parameter here is initialized to 2, and 2 plus 3 here will give you 5. So this function here is accessing the variables in the outer function. So even if the outer function is done executing, this inner function is bundled, let me say bundled with the environment of this outer function. And then anytime this inner function is being called, it remembers the variables in this outer function. And you can even come over here and say, let L equal to 20. And then you can say, let M plus N plus L. And then this will still work as expected. Then you run node closure, then you have 25 because L is still within the lexical scope. So this inner function will still reference L. So this is basically how closures work. So this is a basic example, and then we've learned a lot here. We've learned how to initialize default parameters. We've learned how parameters work in a function, and we've also learned how to return values in a function or return undefined explicitly or implicitly. So what we're going to be doing now is looking at another example. This is also a basic example. So for this function, we will not call this, we'll leave it so you can later reference it. But if you want to just play around with it, you can change things within the function and then call this function twice. We call it pass the result to a variable and then call that variable because when you call this function, it's returning an inner function, which you need to invoke and then pass a variable as well. So now let's look at a function. Let's say a basic counter function. So let's say this function creates a counter. So let's call it create counter like this. And inside of this function, what we do here is we say let count equal to 0, like this. So let this function return an anonymous function. So return function. And inside of this function, we can use the count to do whatsoever we want to do with it. So inside of the function, we can increment the count and return the count, or do whatsoever we want to. Okay, let's say we'll increment the count. And then what we do here is return count, like so. And what we will do here is we can basically come below here and then call this function. Remember, it's returning an anonymous function. So we say const, okay, let's say C1. Let's keep it simple. Let's say C1. C1 is equal to create counter. We say const C2 is equal to create counter as well, like so. So we can come down below and then say log C1. You know, this function, when we call the create counter, it returns the inner function and then pass it to this constant C1. So C1 is also becomes a function. So we need to invoke it. We can't just log it like that. It's a function. So we need to invoke it. Then we say log C2. And now we can go ahead and run our code and see what we've got. We've got 1 and 1 because we're incrementing the counter and then returning it. Okay, so basically, we have two. I mentioned earlier that whenever every closure have a copy of the lexical scope, that is the copy of the variables and the environment of the outer function. So what happens if we call C1 for the second time? Log C1. Let's invoke C1 for the second time. And then let's log this to the console. As you can see, we have 1, 1, and 2. And the reason why we have 1, 1, and 2 is because when we invoke C1, C1 has a copy of this scope, of the outer function scope. So it uses that to evaluate whatsoever we are doing in the inner function. This function, it uses the copy it has to do this. And then we'll call C2. This is a different copy of the lexical scope altogether. So it uses that to evaluate again, because this has, wherever we invoke this function, the inner function has a different copy of the outer function's body, which is called the lexical scope. So we have two here. They all have different copies of the lexical scope. So we call C1 and we call C2. We're invoking this function twice, which have different copies of the lexical scope. So when we invoke this, the first one again, this time around, this has a unique copy of this. So it's using that copy when we evaluate this, let's say we invoke this function, it gets the count to 0, increment it, and then holds the value. The value is 1. It holds onto the value because it's a referencing count. It's a reference, not the value actually. It's a referencing count from the outer scope. So when you invoke it again, it will look at count. Okay, so they already invoked me, and I can see that count is 0. So what I basically need to do is just take count again and then increment count. So this time around, it will grab count, which at that time count is 1. And then what it will do is it will increment the count to 2 and then return the count. So this time around, we have our count to be 2. And the same thing if you say log C2. If you run this once more, we have 1, 1, and 2, 2, because each has a unique copy of the outer function's body, which is a lexical scope. So this is basically how closures work. So if you're wondering what count is doing, what is count plus plus, maybe you have difficult times understanding count plus plus. This is a shorter syntax for saying count is equal to count plus 1. So this grabbing count is 0, and then you say count. Since count is a variable, it changes during runtime. So you say count, you say 0 here now is equal to 0 plus 1. And then 0 plus 1 will give you 1, which will reassign it to the initial count. Then the value will become 1. So this is a shorter and cleaner syntax, which is count plus plus. Okay, so we've said much and we've learned much. Do you have any questions? If you have any questions, you can go ahead and ask, and we'll see how we can get to understand it better. I believe you all can hear me, right? Okay, so if you have any questions, great. If you have any questions, you can go ahead and ask. Okay, so in absence of any questions, so we've seen how we moved a step further to see how to demonstrate how each function call creates a unique copy of the lexical scope. Okay, so now that we've seen that and we've seen how closures can work, and how we can even use closures to create unique copies of the outer function scope, we can even move on to look at private variables pattern. So maybe the variables inside of this anonymous function, you don't want them referenced, or you don't want them to be accessible outside of this function. So we can go ahead and then give another example. And in this example, let's say we'll call this function, this will be a bit complex than the ones we've looked at. So we can call this function, then we call it bank account. So we can, in our bank account, we have a parameter of initial balance. And inside of the function body, we can reinitialize this. Let balance equal to initial balance. So this is basically our bank account. We pass in a parameter of initial balance, and when an argument is being passed, which will be the value of this parameter, then we reassign this balance to that. Let's say we pass an argument of 5, then we say let balance equal to initial balance, which will be equal to 5. Okay, so now we will return an object, and this object will hold a couple of methods, because functions in objects are called methods. So we return an object, and this object will have a couple of functions which are referred to as methods in object. So we have a deposit method, which actually returns a function, and which is which is referencing this function, and then the function will take a parameter of amount. So what do we want to do with this amount? We want to actually deposit this amount in our account. So we say balance, because we have to reference our initial balance and then increment our initial balance with the amount we want to deposit. So what we say, balance is equal to balance plus amount. Okay, so we don't want to do that. We can say balance is equal to balance plus amount. So you should know the difference between balance plus plus and balance plus is equal to balance plus amount. This, if you want, you can say balance is equal to balance plus amount, which is different from what we did earlier, which is different from this. So instead of doing this, you can say balance plus is equal to amount. Saying balance is equal to balance plus amount. So if you have a balance of 5 naira, and then we pass in an amount of 20 naira, we can basically say balance is equal to 5 naira plus 20 naira, which will give us 25 naira. So right now we've manipulated our balance, incremented it. So the next thing to do is to return balance, the new balance, because we've taken the old balance, added our deposited amount to it, and then we'll return a new balance so we can either see it or do something else with it. So we have another method, and then we can call this method withdraw. So the withdraw method also takes another function. This is an anonymous function with an amount. We want to withdraw money from our account. So how do we withdraw money? So there's what we call defensive programming. So in defensive programming, we want to avoid errors by all means. So we'll have to check. We don't want to steal money. We don't want to take other people's money. So what we want to actually do is this. We want to say if amount is less than or equal to balance, that is when we want to withdraw the money. If not, because if the amount is not less than or equal to the balance, then we don't have enough money to withdraw, given the amount. So we don't want to withdraw more than we have in our account. So we see balance now is equal to balance minus the amount. This is the same thing as saying balance is equal to balance minus the amount. Balance is equal to minus equal to amount. That is the shorthand for that. So after withdrawing, we return the new balance. Now we've withdrawn our money, and we withdrawn the amount we want to withdraw. Let's say we have 20 naira and then we withdraw 10 naira. So we want to look at our balance. We return the balance, which will be 10 naira. So we have cash of 10 naira, which we've withdrawn, and then we want to see our balance. So we return the balance. That's great. But what if we don't have enough money in our account? We just say return insufficient funds, something like this. I guess this is how banks do it. Return insufficient funds. That is, we don't have enough money to actually withdraw. Okay, so maybe we don't want to withdraw, we don't want to deposit, but we want to see our balance. So we have another method of get balance. And in this method, what we're going to be doing is we just want to see our balance, nothing more. So what should we do here? This is an anonymous function. And what this function does is it returns the balance like this. So now we have our function here, our bank account function. So how do we deposit, withdraw, and actually see our balance? Okay, so let's open an account. So let's say this is a banking system. So the first thing to do is to open an account. So say const account is equal to bank account. And then we pass in, let's open an account with 100 naira. Okay, so before we proceed, before we open our account, I want to ask you questions. Is this a variable? Const account, is this a variable? Okay, you have 10 seconds to actually attempt. If you know, you can. Is this a variable or a constant? Okay, so it's a constant. Great. So what can you call this? The account here, the name, which is account. What can you call it?
A function.
Okay, so we have balance here and we have account. This is declared with let, and this here is declared with const. So what I want to make clear to you is a constant is not a variable. The reason why this is called a variable, if you declare this with var or let, let's say let or var, those are variables, but this is a constant. Do not make that mistake of calling this a variable. The reason why this is called a variable because it varies during runtime. we have let here, and then we are modifying this. We're actually modifying this here. It varies. We're actually changing it, but we cannot change this. This is a constant and it is not a variable. A constant is not a variable. A constant is a constant and a variable is a variable because we cannot modify this. It is a constant and not a variable. So when they say you should declare a variable, do not use const. Well, if they say you should declare a constant, that's when you use the keyword const. So I just wanted to make that clear because I never knew the difference. But the difference is the reason why it's called a variable because it varies during runtime. You can actually change the values and then reassign other values to it. But a constant, you cannot do that. Okay, so let's move on. So now that we've opened an account with 100 Naira, we can actually go ahead and deposit. So now our account, this constant here holds the deposit, the withdraw, and the get balance method. So if you hover over it, you will see them here, as you can see. Account is an object with this method, deposit, withdraw, and get balance. As you can see, the balancing requires an argument of amount. The withdraw requires an argument of amount, which returns any, because this is not TypeScript and JavaScript doesn't even know what this is returning. We can actually return a string, a number. JavaScript doesn't care. If it encounters an error, it will just throw an error. Okay, that is what you're trying to do is wrong, but it's loosely typed. And that is the reason why they introduced TypeScript. So how do we withdraw money now? Okay, so we can see account. We want to withdraw. How much do you want to withdraw? Maybe we want to get a new laptop at 15 Naira. So account. Okay, let's first of all add money because after opening this account, we got paid. So we want to deposit. Deposit. We were paid 17 Naira. So we can just want to see the value. You can see log this. Oops, this. Okay, so if you go ahead and run this node, okay, this is okay, node closure JS. Oops, cannot find module. Okay. Okay, so now we can go ahead and run node closure JS, and then we have 170 Naira because what we have here is 100 Naira, and then we deposited 70 Naira. So we can even go ahead and withdraw money. We can say, okay, we can basically say, okay, instead of depositing 70 Naira, we want to buy a laptop at 50 Naira. Say withdraw. Then we change this to 5, which is 15 Naira. So we can go ahead and say node closure JS, and then we have 120 because we deposited 70 Naira, which made our balance 170, and then we withdraw 15 Naira to get a new laptop. So now we have 120 Naira. That is awesome. So, but then what we're trying to look at is we cannot access these other variables. That is balance is private. You can't access balance directly. You cannot access balance directly. So you can only manipulate balance inside of these methods here, but you cannot access balance directly. Okay, let's see log account. Then you can see the method. There's no balance. If you want to get the balance, you must call the get balance method. So let's call this. So this time around, if you go ahead and then run this, you will have one to, because when you withdraw, it will show your balance. Or we can go ahead and add some meaningful descriptions so we can understand. So here we say deposit. And here we say withdraw. We say withdraw. And here we say this is our balance. Balance like this. Okay. So now if you run this, let's clear our terminal and then run this once more. So when we deposited 17 Naira, we had a balance of 170. Then we withdraw 15 naira. We had a balance of 120 naira. And then we actually want to check our balance and know that, oh, this is what our balance is. And the balance is 120 naira. So this balance here, you cannot access balance outside of this function. You can only access balance inside. So this closure is very, very useful here. The inner method, we're actually manipulating balance, but you cannot access balance outside of here. So this is safe. You can actually use balance to do whatever you want to do with it inside. And then let's say we want to withdraw 200 naira. Then we have the withdrawal is insufficient funds. And then our balance is still 170 naira. That's sweet. So you cannot access, there's no way to access balance. So it's a private variable only used within this method. So that is another use of closures, the private variables pattern. So that is sweet. We have other patterns, which is a module pattern, which you can actually, maybe you have an array of objects or anything you want to do, you can actually manipulate that privately and make sure it is not accessed outside of that function. But we're not going to be looking at that because of time. What we're going to be looking at is we're going to be looking at a unique use case. So why this is unique is because it is very, very tricky. I'm going to be running a for loop. Say for, then we say var I is equal to 0. I is less than 4. You say I plus plus. And then inside of this, what we're going to be setting a timeout that calls every 100 milliseconds. So we say set timeout, and the timeout takes actually the timeout and a callback function. So what we pass in a callback function here, and then we pass in a timeout of 100 milliseconds. So inside of this set timeout function, what we want to do is actually log I. So let's run a function once more. Node closures. Ooh, it's blown. Poof. Can you see this? This is not what we expected. What we expected was to have 1, 2, 3, and 4. And do you know why? The reason why is because variables declared with var are hosted in the function scope. Or if there's no function, they are hosted in the global scope. Hosting means they are moved to the top. So by the time the set timeout executes, this set timeout is referencing the variable in the global scope. So before this set timeout executes, this for loop is done running. So it doesn't have a unique copy of this I. What it's referencing is the I now becomes 4. The 4 I's we have in the global scope, they become 4 because it increments. It's a variable I and it's hosted globally. So it increments, all of them increments to 4 because we have just a single I, and here it is not captured in this closure, this function here. It's a global scope. If you use let will be captured in this closure here because it's a local scope. It's being referenced in a local scope, not a global scope. But this var here, it's a global scope. So all the I will be incremented to 4 because this set timeout function runs, and it will log 4 to the screen. So what is the solution to this problem? The solution to this problem is basically use let. Now, once more, let here, with let, you are basically saying, okay, we have 1, 2, 3, 4, and then we are saying for each I, log I, like this. Okay. For each I, this is basically what you are saying. Okay, so with this, I don't want to talk about this. And if I remove this, JavaScript knows that we have to terminate this, and this is the reason why it's adding a semicolon here. But if I add this and then save, remove this one here, add this one here, and so what's happening? Okay, so that's by the way. I don't know what the linter is doing like that. Well, right now, if we go ahead and run this, and then we have 1, 2, 3, and 4. But if you want this to look like that, we say I plus 1, because this will start at 0, indexing at 0, because this is referring to the index of the array. So let's remove this and then focus on what we are talking about. So here we have I is equal to 0, I is less than 4, I plus. So in every set time, inside this function is a closure, and every time you call it, it's returning a unique copy of this I. So when this for loop runs, the first time it runs, the I is actually 0. And when it runs again, I will be 1. It will run for the third time, I will be 2. It will run again. So all those times, this function is capturing the variable I. Because remember, anytime a closure is called, it will reference, it always has access to the unique copy. So before this set timeout is called, the for loop is done running. So the function here captures all those local variables in its outer scope, which we have those times we have I to be 0, 1, 2, 3, 4. We have something like this. So this inner function then we capture all this. We say this set timeout will run 1, 2, 3, 4, 5 times, and then it will capture all this I. It will run 5 times. But okay, when I was running at first, what I saw I is 0, and then the second time I is 1, third time. But for var, it is hosted globally. If you say var, it is hosted globally, and then if you try to capture it here, what you are referencing var I, which is a global scope, and all they've incremented to 4, because it doesn't capture it here as a unique reference to this I here. It captures it as a global variable, and it's hosted. When JavaScript starts to execute, it's hosted at the top, which will increment all the I to 4. So var here is very confusing. So there's another solution to this. You can go with IIFE, immediately invoked function expression. So what you will do is, each time you want to, you can actually go with, you can do something like this. Okay, let's quickly go over it before we move on because of time. You can actually return your var, or in the var, you can do something like, we have an immediately invoked function expression. So here we have a function like this, and then we pass in a variable, an argument, sorry, because in this function, we need an index. That is an index of the loop. So how do we access this index? As I earlier said, this is a variable declared, but the value here is undefined till we pass. This is an IIFE. And passing variable arguments to an IIFE is doing something like I. We want to pass I. So anytime this loop runs, pass the argument, pass the I. So when it runs the first time, I will be 0. Pass the 0 here, and then allow the function to execute. If it runs for the second time, pass I to be 1, allow this inner function to execute. So what do we want the inner function to do with the arguments being passed to it? We want to call the set timeout. And the set timeout will take an anonymous function. That's a callback function. You can give it a name actually, but I love to make it anonymous, and then you pass 100 milliseconds. And inside of this, we see log index. And then our problem is solved. So actually, you can go ahead and then run this. And then we have 0, 1, 2, and 3. That's nice. So we've solved our problem. So any questions, please? Okay, so in absence of any questions, I'll take it that closures, we've safely explained closures. So we're moving to prototypal inheritance. Great.
Good. So, excuse me, I have a question.
Yeah, you can go ahead, Nicholas.
Yeah. So, just to draw a conclusion from what you said about closure. So, can we say closure is a function, or can we say closure is a process? I don't know if you get.
Closures is actually it's actually not a function. A closure is a function that has access to variables, its outer function, but closures itself is actually a concept. Let's say closures is a name referred to those functions, but a closure is a function. You understand?
So, it's a function.
Yes. Or we can
So, you
say
can say that.
closures. Closures is a general name for those functions.
So, which of them are called closure? Is it the inner function or the outer function that is called the closure, or the concept of both of them being joined together is always called closure?
Exactly. When you right now, if I remove this, this is no longer a closure. But once I bring this in, an inner function, we formed a closure. Do you understand now?
Okay, so it's the concept, Abi?
Exactly.
Okay,
Actually.
okay. All right. Thank you.
Okay, so moving on, we have prototypal inheritance. So this has to do with objects and all of that. And we've come across this as JavaScript developers, but maybe we actually didn't understand it very well. So we try to understand prototypal inheritance. So other languages like other object-oriented languages like Java, Python, C# and the rest, JavaScript doesn't behave like those languages. So it uses prototype-based inheritance. So do you know what a prototype is, right? Let's start from there. So a prototype is just like an initial version of something that other versions can be built on. So before you release a product, you have to build a prototype and then test it out to see how it behaves, how everything works out. And then you all you need to do is continue building on top of that prototype. So we can basically say prototypes than an initial release of a product or an item or something like that. So every object in JavaScript has a hidden prototype called, it is actually called a prototype. Okay. So let me show you here. It is called this. If you invoke a function, you see something like this prototype on the console. So it is called a prototype. And how you can access that is using this proto. That is how it is being accessed. So we have every function or object has a prototype that you can reference. So how prototypes work is basically when you access a property on an object, JavaScript will first of all look at the object itself. So when it look at the object and you cannot find that property you are trying to access on that object, it will look at the object prototype, which is this proto. So if you look at a string, this is a prototype. This string, if you call a string and then you pass in something like some, then you see dot. This here is a prototype, and all these are on the string prototype. So even if you declare a string, let's say const name, a constant, then you see proto. Now, JavaScript knows that what you are trying to do here, you are declaring a constant that points to a string. So if you say name, okay, so this doesn't have autocomplete, but I can say log, let's say name dot to uppercase or something like that. You actually change this name to uppercase. So JavaScript, since this is not a reference type, this is basically not a reference type. So JavaScript will look at this. Okay, this doesn't have to uppercase method. That property to uppercase does not exist on the name. So it will look at its prototype, which is this. This prototype holds the to string or to uppercase method. To uppercase method. So it will call that on that and then invoke it on this, changing this to an uppercase proto. P, capital letter P with small letter ROTO. So when it keeps searching, it will first, if you have any, let's assume you have PN is equal to proto. And then you come over here and then you see name is equal to PN. So it will look at, if you try to say name dot to uppercase, it will look at the name. Does the name have to uppercase? It doesn't have that property or method. It doesn't have it. So it will search and go back to PN. Does PN have it? PN doesn't have it. So what is the prototype of this PN? The prototype of name is PN. Let's say the name is actually grabbing the value from PN. And it will look at PN. What is the prototype of PN, which is the actual object prototype in JavaScript, which is the proto. It will look at the proto and then say, oh, this has a to uppercase. So let me grab that and then invoke that on this. So this is a value, not a reference. PN is equal to this. It's immutable because the value of PN is proto and nothing can change that. So what JavaScript will first of all do, it will first of all convert this to an object. And then after converting it to an object, it will invoke that method it found on the proto, on the string prototype. It will invoke it on it, converting this to an uppercase, and then turn it back to a value as it is. So that is basically how JavaScript behaves. That is not something we talk about in this class. But what I was trying to explain to you is JavaScript will first of all look at that object you are trying to call, and then that object itself. So if it does not find that method or property on it, it look at the object prototype, and then it continues to it will continue up to the prototype chain until the prototype is found or null is reached. So you have 5 objects, and then the 5th object is trying to access the toString method or the toValue method. So JavaScript will start from that 5th object, and then it will look back to the 4th, 3rd, 2nd, 1st. And if it cannot find the toString method, it will look at the actual prototype, the inbuilt prototype in JavaScript that is being inherited from, and then it will grab that. So if you cannot find that method on that prototype, it will return null, and then it will throw an error. So that is basically the prototype chain. So if the prototype itself isn't found anywhere in the chain, undefined is returned. You know, when it search and it cannot find the prototype, what it matches is null because the prototype is not found. So it will hit null. But then if the prototype isn't found, what will be returned is undefined. If you cannot find it, it will reach null because I cannot find it and my bus stop is null. But then what it will return, why it cannot find it is undefined. So it will return undefined. So we have constructor functions in JavaScript. We have constructor functions and we have prototypes. So this may be kind of confusing to some people, or at first, if you don't know it, it will be kind of confusing to you. So the constructor prototype is an object that will become the prototype of instances created with the new constructor. Okay, so this is too much and it will be confusing if you don't see an example. So let me say it once more. The constructor prototype is an object that will become the proto. That is the underscore underscore proto underscore underscore. That is, it will become the prototype that other instances we inherit from. So if you declare a constructor function and then you try to create an object using the new keyword, that object you declared with that using a constructor function becomes the proto that the instances we inherit from. So I guess that's more clear now. So this points to the constructor's prototype object. Okay, so I guess I'm speaking too much grammar, and let me just show you this a bit. So we have function person like this, and then you come and you say P1 is equal to new person. So what's happening here is this now becomes a proto. It becomes a prototype that this instance we inherit from. That's basically what all the grammar means. So it points to the constructor's prototype object. So every function has a prototype property, but only constructor functions uses it meaningfully. You understand what this is? So if you declare a function add, and then you see, let's say you return 2. Let's just say return 2. And then what you do here, you come over here and you say add, and then you do something like this. Can you see this? This is what it basically means. It means every function has a prototype. So when you do this, JavaScript will look at this function. Oh, this function doesn't have any of this method. So which method are you trying to call? So let me look at the prototype. So it will look at the built-in prototype, and then we see to fix to exponential, because this is actually a number. What it's returning is a number, to string, value of, and all of that. But most times we don't normally use that. That is the reason why it is said, but only constructor functions uses it meaningfully. Because here you can see this constructor function here can return a method, and then you call this P1 invoking the method in the person constructor function. So we've briefly discussed the prototype chain, but then we can actually visualize what the prototype chain is like. So we have an object, and then it will search that object without finding it. It will move to the constructor prototype. So from here, we have P1. Let's visualize it a bit. P1 here. When it doesn't find something, it will move to person. That is the constructor. If the constructor have that method, it will use the method. But if it doesn't have it, it will move to the input JavaScript prototype, which is the object prototype like this. If it doesn't find it, it will move to null. At this point, it will return undefined, because it started from here, searched through this person, through the inbuilt object prototype in JavaScript, and then arrived at null. So at this time, it will return undefined, like so. So that is basically the prototype chain. So if you have this is basically the chain here. It will start searching from P1, move to person, and then move to object prototype, and then move to null if you cannot find the method or the property you are trying to invoke. Okay, so there's a mental model to this that we actually got to grab so we can be safe. So think of prototypes as templates or blueprints. Yeah, they're actually templates. As I earlier mentioned, a prototype is actually let's say an initial version of a product you build, and in order to later build on top of that product. So a prototype is actually a template. Let's say that initial version is a template that you want to use to build other products of that kind, or blueprints, templates. You can anyhow you want to refer to it as. So a prototype as templates or blueprint that objects can inherit from. So when you can't find something in your house, that's, for example, you will check your parents' house, and then maybe you check your grandparents' house, and you check your great-grandparents' house. Maybe you feel that is the chain, because if I can't find this in my house, I'll check my parents' house. If it's not there, let me check my grandparents' house. Maybe my parents did not take it from there. If it's not in my grandparents' house, let me check my great-grandparents' house. If you cannot find it from there, there's nothing. That is null. So when you are returning home, what will you return with? Nothing, undefined. That is basically the mental model. So with this explanation, I guess you understand the prototype chain and the mental model behind it. So the proto is actually the instance property. This proto here. Let's see. This proto is the instance property from the person. That P1 is an instance of that person. So this proto is the instance property. Why the prototype is the constructor property. Prototype like this. Let's say object prototype. This is actually the constructor property. The constructor, that person constructor. Why this one here is the instance, the P1 we created. This is its own property. Why the prototype here is the person constructor property. And the things you have to also bear in mind is the new keyword. Anytime you invoke a constructor function or a constructor function with a new keyword, you are creating an instance of that object. It's actually an object. You are creating an instance of that object. So you can use object create for direct prototype setting, or you can use the prototype chain traverser and property lookup. Anyhow you want to do it, we look at those. And then we have shared method versus instance properties. So we've spoken more and more, and we've talked about the prototype chain, the constructor functions, and all of that. So we should basically look at what these are. So function, we say, as I earlier mentioned, let's say person. And this person here, name, age. So inside of this person, we say this name is equal to, not global this. That's the global object. This here, dot name is equal to name. Then we say this dot age is equal to age. So this is a constructor function. So this is a blueprint that we want to use to create other people. We can create 100 people from this. We can create 100 people, 1,000 people, 1,000,000 people. But we don't want to come back every time and then say const P1 is equal to this. And then we say name P1, age P2. These are reference types. If you create an object like this and then create another one like this, P2, these are two very different, unique objects in memory. They have nothing to do in common, absolutely nothing to do in common if you have something like this. So this is actually, you don't want to do this. You don't want to keep doing this and polluting your environment every time. You just want to have a constructor, let's say a blueprint or a template that you can use to create all of those. So this is what this constructor function serves to be. So what we can do here is we can actually add methods to our constructor function. So how do we add method? As you can remember, I mentioned something, object prototype. This person here is an object. So since it's an object, it has the prototype method, or let's say the prototype property. So what we can say is person dot prototype. So we want to add the greet method on this person prototype because it has a prototype that we can actually look up to. So we can say dot greet, or we can say person prototype is equal to, then we open an object and then we say greet, and then we have a method. But this is not or if it's TypeScript, it will throw an error. but we can work around that. But for now, we can say dot greet is equal to a function that is an anonymous function. So what is this function doing now? The greet is actually a method. So what we do here, we see return. We can use template strings, or we can use, we'll be talking about ES6 in our next class. For now, let's just use the regular method. Hello, I am, they'll say plus. This is concatenation. This is not addition. This dot no, what's this? This dot name. And then, can you see this? This is wonderful. So we already have this, the age and the name on the prototype of this person here, this constructor function. So once we add this to we try to access this. This is referring to this. And then we have the age, the greet, and the name, because we've added the greet to the prototype. So we can say this dot name like this. So we can even go ahead and do something more meaningful. Or should I say more, more meaningful, say person prototype. They will say get age. We want to know, no, this is, we assign this to an anonymous function. So we want to know their age, and they will say return this age, like so. Okay, so now the reason why it is called a constructor function is because we can use it to construct a whole lot of objects. So let's say we have const p1 is equal to new person. Nope, new person. And then we can pass in, let's see, KodeCamp. And then we'll pass in 5. So paste this once more. We create a new object from it. That is an instance, which is an object from it. And then we'll say code, this time around, say code house. Then we'll pass 10. So we've constructed 2 objects from this function. Let me just put it that way. And then this time around, this has methods. It has the greet method and the get age method. So if you come over here and say log p1 greet like this, you can say p1 get age. Now if we execute this, and then we say okay. Prototypal inheritance. Okay. Yes. Okay, so now we have hello, I'm KodeCamp, and then we have 5 right here. Because we have methods here that are doing that. So we've added the greet and the get age to the person prototype. So they are now part of the person. So we have, hello, I'm KodeCamp, and you can say, I am 5 years old. Then I'm 5 years plus age. Then it will log, I'm 5 years old over here. So what actually is this? Okay, we'll talk about the this keyword in a bit. But for now, this is just a constructor function, and we can add method as much as many methods as we want to this person prototype. So let's remove this and then move on. We have, you can see, we can have children constructors and then the parent constructor. So we can say we have function animal, and this animal will take a parameter of a name. Then we can say this is equal to name. And now we can add a speak to this animal. We can see animal prototype speak is equal to function. And in this function, we basically return this name. And then we see we'll concatenate it with basically a string. And then we say makes sound like this. So we've added a speak to the animal prototype that any instance created can basically inherit from this prototype. So we'll go ahead, and what we do now is create a child constructor that will inherit from the parent constructor. So in the child constructor, we'll say we have a dog function dog. This is a constructor function, but it's actually the child constructor. They will pass in a name and breed. So what we want to do is we say animal, that is the parent constructor. We want to inherit from this. They will say dot call. What do we want to call? We want to inherit the name, this. Then name, like this. So we are inheriting the name from the parent constructor. And then let's bind the breed. This is called binding. This breed is equal to breed. So we are binding the breed. What we do here, we bounded this name to name. And here we're also binding this breed to the breed. But here, the name here, we want to inherit the name property from the parent constructor. So how do we go ahead and do this? So we can actually set up inheritance. We can see for us to set up inheritance, we can go ahead and do something like, okay, dog.prototype is equal to object create. And then we can create an object that is the animal prototype. Can you see how cool this is? And then we can add a dog, we can add a back method to the dog. You can say dog prototype back is equal to function. And then we can say return this name. Then we concatenate it with backs like this. That is the dog backs. Any dog name that we pass in there, the dog we back. Okay, so now we can go ahead and do something like let's say my dog is equal to new dog. And in here we can pass a name Stan. And then we see a cookie, something like this. And then we can go ahead and say log my dog. Should it back? Okay, let's say it backs. Back is a method. So we invoke it like this. Then we can go ahead and run our file. Stand backs. Okay, so as you can see, what we basically did here is we had a parent constructor. We add methods to it. And we can say log my dog. What's the other method again? Speak, right? Back. Okay, actually, this is the parent speak back dog. Is there a speak method? Yeah, it's a back. Okay, speak is on the animal prototype. So we can basically, what we are doing here is we are creating an object, the animal prototype, and then we're adding a back method to it. Okay, so stand backs. So the breed here, we're not using the breed to do anything. We can say stand, and then we can say plus is of breed. Then we can say plus this breed. Can concatenate it with and it's okay. Can just come over and say and it's backs like this. So come over here. Oops. Okay. Please let me just get this out of my way. Okay, so this, and then we run this once more. We run this once more, and then we have stand is of breed a cookie and it backs. So we need some spaces over here, here. Come back here. Run it once more, and then stand is of breed a cookie and it backs. Okay, so we've inherited the name from the parent prototype, and we are actually using it in a child. Sorry, we inherited the name from the parent constructor, and we're actually using it in the child constructor by using the call. So we're binding it to the child constructor using the call method. So we can basically go about this using the object create pattern. So these are two different patterns, but we can go ahead and then use the object create pattern. But that we won't be able to do because we don't really have time. So what we're going to be doing here is we'll skip the object create, that is inheritance with object create, and we look at inheritance with EX6 classes. Okay, so with EX6 classes, we can just go ahead and say class. This is just syntactical sugar to function constructors. So we can just go ahead and say something like, okay, class shape, and then we say constructor. This is how in ES6 it is being done, name. And you will bind the name to the constructor. So this name is equal to name, like so. And then you will see it's actually a shape. So let's describe the shape. This is a method, and this is how methods are written in classes, that's in ES6 classes. What we do is we will say, okay, return, since this is ES6, let's just use template literals. You say this is a, then we can see this name, like so. So how do we go ahead and use this? It's the same thing as using, but then before we use it, let's see how inheritance works. We can say class, then we say rectangle, and then we extend. So we want to inherit from shape. So extend shape. This is inheritance. Now we are inheriting from shape. They will say constructor. Let's put in the width and height. So how do we reference? Now what we do here is this, we bind the width and height to, to the rectangle class. So now we have our rectangle that extends shape. So how do we go ahead and use this? Now we'll come over here. We see, okay, let's say new rectangle is equal to new rectangle. So what do we pass in? We pass in a width of 23 and height of 45. Okay, so we actually did not do anything meaningful here. We can actually say return area, and in the area method, we just return the area. So you return this with multiplied by, I think that's how area is calculated. I guess so. Height. So we want to invoke the area method. So we say log new rectangle. Area like this. That is actually a number. They will come over here, clear the console, run it once more. Okay, this width. Times must cause super console. Okay. So super. Oops, what's this? Super, like this. And the name, okay, let's say rectangle. So we are inheriting from here, and then we forgot to call the super. So we can come over here, clear console, and then run this. Okay, none. Return this with this height. Width, height, this height. Okay. I will control width, height. Okay. This is equal to width. And down here, this is equal to height. Okay, so let's run this once more. Okay, so now we have 1035. So we now get the area. So we can come over here and just see okay, so basically you can do, you've inherited from this. So the method, the name here, you can use the name here. You can call super. What we are calling call this, that you can pass in the name, this name here, like this. You can say something like name like this. And then we can come over here, then run this once more, super this name. Okay, so what's happening here again? Okay, you can just give it a name or not. Okay, this name. Okay, so once we call super, we're already extending the shape. Super here, it's letting this class know that we're inheriting from the shape. Okay, so none. Okay. Because of time, we are just rushing and we cannot concatenate numbers with strings. So let's say get name. And in the get name, we return this name. Then we say here dot get name, like so. So once more, clear and run, undefined. Okay. Shape name. Okay. Okay, so shape name here, name. Okay. Sorry about that. Oh. Okay, for some reasons, because I'm in a hurry, I'm forgetting something. But then you can go ahead and experiment with this and then pass in, because this is basically inheritance. And then the name, we have to access it in here. Super, I'm just trying to get this right because we don't have that time. Okay. This is the rectangle and one more error. Great. Okay. So we have name. So now what we are trying to do is basically inheriting from the shape. And then we can say, okay, log nr name width height get name describe. So we can call the describe method here. Then we can run our function once more. And this is stan because we've inherited the shape and then we've decided to add more methods to the inherited class. So this is the base class, and this one here, this is the super class, and this one here is called the child class. So we've inherited from the super class, which is also known as the base class, and then we called super to inherit from it with the name, because we also want to get access to the name. So in here, I guess we are calling describe on new rectangle because we've inherited from this. And this has a method of describe, so we can access it from here. So this is basically how we inherit using ES6 classes. So any questions? Due to time, I was kind of in a hurry and forgot to bind and do all of those. So in absence of any questions, let's move on to functional programming. So functional programming is basically it's, let's say it's should I say it's a philosophy, because you can say functional programming philosophy, something like that. So functional programming it's a paradigm, right? It's a paradigm that treats computation or okay, it treats computations as an evaluation of mathematical functions. So it emphasizes on like building programs by composing functions and avoiding changing states and mutable data. So if you know libraries like React and all of that, they heavily rely on functional programming, especially React version 16 and above. So they ensure immutability, and it also makes sure that people using React doesn't mutate data, because that will cause problems. So in functional programming, as I realized, it's actually a programming paradigm that treats computation as the evaluation of mathematical functions. So a function is basically, you can call it as a mathematical function, because what you pass in as parameters, it expects those arguments to be able to run the way it's supposed to run. So in functional programming, we have pure functions, which are the foundation of functional programming. So if a pure function itself is a function that it's let's say it's deterministic, so it always returns the same output for the same input, and then no side effects. That means doesn't modify anything outside its scope. It does not modify anything outside its scope. So it always returns the same output for the same input and no side effects. And also no external dependencies. Doesn't rely on external state that could change. So it has to take the argument supplied is what determines the output, but it returns the same output for the same input. So why does pure functions really matter? So, we have testing in software development. So they are predictable and testable. So just imagine you want to test a function that mutates, let's say mutate state or causes mutations. It mutates variables outside of its environment. So that would be hard to test. But then with pure functions, you can predict their outcome and can test them. So they are also easier to reason about and debug. So if you have any issues with your pure functions, they are easier to reason about and also debug, and can be safely cached. That is memoization. You can safely memorize pure functions, because everything is passed as an argument, and everything you're doing is within the function body. But by the time you pass an external dependency or external variable that is causing side effects, memoization becomes harder. And then it also enables parallel processing. And it composes naturally with other pure functions. So function composition. I believe we have a little time to talk about that. So under pure functions, we have immutability. Under functional programming, you have immutability. So there's what is known as the immutability principle. So instead of modifying existing data structures, create new ones within the desired changes. So this actually prevents unintended side effects and makes code more predictable. So you don't want to mutate, you just create. It's called cloning or copying. You create or you clone. Instead of mutating, you create new ones or clone the other ones and then try to modify them and do whatever you want to do. And then we also have higher order functions. So functions that either take one or more functions as argument or return a function as their result. So this enables powerful abstractions and code reuse patterns. And throughout this bootcamp, we'll be seeing how all these things are very, very useful. And we have function composition under functional programming. So function composition is a process of combining simple functions to build more complex ones. Okay, so let's think of function composition as building blocks, little or small building blocks that you can combine to create complex structures. Okay, let's say like building blocks. Let's say we want to build a house, so we use bricks or blocks, these blocks that we can bring cement and then try to put them together to make it a building. So those blocks are little functions, and then we compose them together to form something complex, which is the actual building. And functional programming also has principles. So it prefers, one of the principles is number one, it prefers pure functions over impure ones. it uses immutable data structures. That is the second one. The third one, it leverages function composition for complex operations. So it treats functions as first-class citizens. Actually, functional composition treat functions as first-class citizens. So it avoids shared mutable states. It doesn't take in shared mutable states. So it's use declarative rather than imperative style. So it doesn't use imperative style, it just use declarative style. So due to time, I'll just give you a simple example of pure function and impure function, then we will quickly round up. So I will just do that in this file. So what we have is a function, add a, b, return a plus b. So this is a function and it's pure. This is a pure function. So if you pass in add and you pass in 2 and 3, it's predictable that this function must return 5. There's nothing that can be done that this function will not return 5. It must return 5. Okay, so let's see, we have another function. Let's say let total equal to 0. And then you say function add total. Then we pass in amount. Then we will say total plus equal to amount. Right? Then what are we returning? We are returning the total. We are returning total. Okay, so for instance, you call this function, okay, return. So you call this function and you pass in 5. You see, add total, and then you pass in 5. At this time, total here was 0. You are expecting to receive you are expecting this function to return 5, right? What if this changes now to 89? The result will be 94, and then you'll be wondering, why is this function returning 94? Because you thought total will be 0, and then the total is being modified. Let's say something here, let's say this one now, before this function call, there's another function call here that modifies total. I say let total here is 0, and then say total is equal to 89. So now if you call this now, instead of returning 5, it will return 94. This function here is impure, and this one here is pure. Okay, so I think we are out of time, and then we will complete this essentially maybe in our next class. Okay, so do we have any questions so far? Any questions? Okay, so that's great. Thank you all for listening and paying attention. It's been an awesome class. We will meet in our next class, I guess.